So let's get going. Good evening, everyone, or maybe good afternoon from wherever you are, or good morning. So this is Data Engineering Melbourne Meetup. So we met last week on a special session on Airflow, but this is our scheduled session. So today, welcome. And then we have a talk from James about stream processing. And after that, we'll have a community marketplace. Community marketplace is just about, giving everyone an opportunity if they have something they want to talk about. It could be a job opportunity, or in case if you're looking for a job, or maybe you have something to share, which you maybe a conference or something. Yeah, you'll get that opportunity after the talk, and then we'll wrap up after that. So without further ado, I'll stop sharing and hand it over to James. Over to you, James.
Awesome, thank you. And I will start sharing. So hello everyone. Thank you for having me at your meetup. So tonight I was going to go through stream processing pipelines and do it with a practical example. So I guess the agenda for tonight is event streaming, like a 3-minute overview. It might take 4, but it's a complex area, and I'm going to try and distill it down into a very, very simple concept. And then I'm going to work through an overview of the demo. So before I do the demo, I'm going to actually talk about what it is the demo is going to do, and what kind of connectivity we're building out. And really, we're focusing on this customer 360 use case, but hopefully the demo will be, I guess, generic enough you can apply that pattern to other problems you may be trying to solve. Then I'll move on to the live demo and what could possibly go wrong, right? So it involves Docker and cloud services and cloud-to-cloud connectivity. So anyway, and then questions. And I do put questions there at the end, but really, I mean, I'm happy to take questions and keep this interactive. I don't think there's any kind of time pressure, so feel free if there is a question, and if you want to just put it in the chat, or if you want to interrupt, I'm totally okay with that. Yeah, so that's what we're going to be going through, and so I might now kick over to the whiteboard. And so starting with this idea of, now I'm just get the zoom levels right, apologies, otherwise my pen doesn't feel right. So starting with this idea of event, if I can write, streaming. And I guess I'm just going to run through a very quick kind of example that will be the foundation for what we're going to be building on. But the whole idea with event streaming is that rather than, you might have, let's just start with a very common situation where you've got an application. That application has some kind of data store, and some users interacting with that application, and that application is actually reading and writing from that data store. And when there are changes to that state, it sits in that database. And when we actually want to find out the current state, we actually have to go and actively query via an API. Right? So if I want to know what the current customer information is, I need to go to that database to see if anything's changed. And so we kind of consider that as sort of a data at rest, or a sort of a passive approach to data. Event streaming tries to flip that. And so rather than the sort of communication being me requesting something of the application, we try to make the updates push out to anybody who's actually interested. All right. And so how do we do that? Well, the first step is here we have our application, our database. The first step is actually to get things into the event streaming platform, right? And so we do that using connectors, and we'll be talking about connectors, and I'll actually be showing connectors and showing them working. But those connectors will actually connect to the data source. And when there's a change in that data source, those connectors will push through into Kafka. And each change will come through as one of these little boxes, which we call an event. And so if you imagine as data changes, these events stream through the platform. And we kind of have this idea of event streaming. And so each one of these boxes or events is actually kind of like a business fact. It's something that happened, and so it's immutable. It never changes. And so we've captured this data, we've moved it from one system into Kafka, but really we need to complete that loop and have a downstream application that is actually going to be interested in that data. And one of the most common initial use cases, and it's one which I'm sure you're all very far more familiar with than I am, is that that notion of the data warehouse. All right, and that means we're pushing that data from Kafka into the data warehouse, and that gives us some nice things, right? Kafka as a technology is built to be distributed, high throughput, highly durable. So there's a lot of benefits in just having Kafka as almost an abstraction layer between the application and a downstream system. But a bigger benefit is that we can now move that data to a number of different places. So we might be moving it down to an S3 bucket. And we may also be moving this to somewhere like Elasticsearch. So each of these downstream systems are really optimized for particular use cases. And so we might say for a data warehouse, it's around the analytics and reporting. For the S3 bucket, this might be a compliance or an archival use case. And then with Elasticsearch, it may be federated search across a number of systems. And so I say a number of systems, but there's only one system feeding in. So another nice thing, in the same way that we can increase the use cases downstream, we can also add new sources of data. And so these sources may come from other databases, but increasingly we see these sources being quite disparate. And so as an example, Kafka is a very popular part of things like SIEM, and that that is meant to be a little temperature gauge, which is an IoT-enabled temperature gauge, which is sending its sensor data into Kafka. And so Kafka is just creating events. Each time there's a measurement, that measurement is the business fact, it's the event, and that event goes into Kafka. And then in exactly the same pattern that we've just seen, those events can be pushed to these other downstream systems. And so this is one of the initial use cases of event streaming and of Kafka. And that's kind of like a use case which some of you on the call will be, is it a call? I think it's a call. Some of you on the meeting, the Zoom, the Meetup would be familiar with, and that's PubSub. And so it's very tempting to think about Kafka and event streaming as, oh, okay, I get it. It's a message queue, right? And to some extent it is. It's a message queue that behaves at scale in a distributed manner. And we won't really talk about the underlying technology and infrastructure that makes that happen unless we want to. But the PubSub is part of the picture. But another part of the picture is storage. And that is the ability to retain these topics for an infinite period. And that's very different from a message queue. Message queue typically will be ephemeral. And the idea is moving data from one place to another, and then that data disappears once it's been used. By introducing storage, Kafka does a couple of interesting things. One, it makes it possible to replay data into downstream applications. And so that can actually be very powerful. We see customers who are doing migrations between data warehouses who will actually store the data in Kafka, and then they can actually, when they go to swap over a data warehouse or even a SIEM system, they can actually reload the data from Kafka without talking to the source systems, and so reducing load. But probably more interesting, with storage, we start to see Kafka becoming a source of truth. And that's a dangerous term to bring up in a data engineering meetup, I'd say, because quite often we think of that data warehouse as the source of truth. From our perspective, and again, maybe controversial, but we see everything down here as essentially an index. And so an index that is optimized for a particular use case. And then moving through, the last thing if we look at this picture as is, that data is being moved from one system to another, but in exactly the same format that it was when it came out of the source system. Right? So, and that may or may not be suitable for those downstream systems. So the last thing we add in here is this notion of stream processing. And we're going to be seeing quite a lot of that this thing. Stream processing, conceptually, quite simple. So if we imagine each of these lines is a topic, a stream processor is really an application that subscribes to one or more topics, does some kind of manipulation on that data, so transformation. That transformation can be stateless or stateful, and we'll see both tonight. And then it produces data to another downstream topic. That topic is pushed back into Kafka and can be shared downstream. And so the technology that we're going to be looking at tonight is KSQLDB, which is a stream processing application, which has got a very sort of like a SQL-like syntax. So it's relatively easy to sort of start, or it's very easy to start with and to comprehend, even if you don't understand stream processing. If you've got a relational database background and you understand queries, it's going to be mostly comprehensible. Anyway, that was, and I didn't time it, but it's probably more than 3 minutes, but that's the overview of event streaming. And so let's move through to kind of like the use case. And so the use case that I mentioned was this Customer 360. And Customer 360 is a really interesting use case because companies really struggle with it. It's been a problem for a long time, and it cuts across pretty much every industry. And even if they don't have kind of retail customers, there's still kind of like relevance in this pattern. And so what we typically see is that we have a number of applications that actually control different facets of customer data. And so we may have kind of like information spread across these data silos. So Customer 360 is the idea that I really want to be able to have that full view of my customer in one place. And obviously, and really across companies, we see like multiple data sources. And I've drawn these as databases, but often they're not. So some of these connectivities that we'll be looking at tonight might be CSV files, because that's how things are stored, and they may be batch processed, etc. So it's that idea of actually bringing this data together to get this kind of like holistic view of a customer. And so what we do is we start by converting these into, as you'd guess, event streams. And then we use stream processing to actually join them together. And so that's the kind of overview of the Customer 360 problem and the challenge of Customer 360. But now I'm going to actually walk through, I guess, a more detailed overview of what we're going to do. And I'm going to identify all of the systems and the steps we're going to do. And then I'm going to show them running. And we're going to see that they are, in fact, running, hopefully. So we're going to start by thinking about, well, what are these source systems that contain my customer information? And so the first one I will have is a customer profile service. And that's just keeping information about the customer, address, name, that kind of thing, right? And so the customer profile, in this case, the actual sort of system of record, so I'll just like write system of record up here. And that was meant to be oh gosh, meant to be a parentheses on the side and a bracket. The profile system will actually be stored in a database, and that will actually be using MySQL as the data store. Then we'll also have some other data sources. So we're going to have this idea of a loyalty engine, right? The loyalty engine is actually going to be collecting data from external parties. So the idea is that there is some loyalty points within this organization that customers accrue by using third-party services. And so those third-party services, they may be sort of like point of sale systems, All right, and so those third-party services will be talking to some kind of service, which is pushing into that loyalty engine. Now, for the purpose of the demonstration, we're going to be generating that data. So that's going to be kind of mock data. It's not going. I haven't gone out and built point of sale parts for this demo. I'm sorry. And then the final thing is we're going to have customer credit ratings. Oh God. Credit ratings, and they're going to be kind of like old school. Okay, so we're getting those from an external service, and the only way they can provide them is maybe they drop them on an SFTP server, and they come as a CSV. So the actual source system here is going to be CSV file. All right. So that's kind of like the organization where they're storing data about their customers. The next thing is, well, how do we integrate this data? How do we do this in a reliable way so that we know that this data is going to be captured and captured in real time, or as near to real time as that source system of record allows? And so that's where we introduce the first part of, I suppose, the Kafka ecosystem. And so this is going to be in terms of the Connect framework. So the Connect framework is part of the kind of Kafka ecosystem of services. And essentially, it's a set of runtimes that run what we call connectors. And these connectors, they always talk to Kafka on one side, but on the other side, they'll talk to a specific system. And so the first connector that we're going to be using is what we call a change data capture connector, which many of you are probably familiar with. And so that will be reading the logs from MySQL and actually picking up those logs and then turning those logs into a series of events. So every time there's a change to the MySQL database, and that's profile information, remember, so that's somebody updating their address with the call center, that updates the system of record, MySQL, so that updates here. CDC captures it, turns it into an event, and adds it into Kafka, into that sort of like event stream. For the loyalty engine, I'm actually using Connect. I'm using Connect, I'm using what we call a data gen connector, all right? And so this is really for this sort of proof of concept and sometimes for testing, so you can mock out data flows. And this data generator, again, will be pushing a series of events into Kafka. And then finally, for this CSV, we'll be using, you probably guessed it, a CSV connector. All right, so the CSV connector will essentially monitor a folder, and when a new CSV arrives, it will actually process that folder, that CSV. And it will turn each row of that CSV into an event. So we're starting to sort of like build out the system. Now, as we move kind of like data into the system, we kind of like initially, when it comes straight out of the connector, we can consider this, if I can choose the right pen, we can consider this kind of almost raw data or a landing zone for data. And I'm sure with you sort of like in this group, data warehouse, you're familiar with this idea of different stages of data. And so what I mean by raw data in this sense is that the schema, as I mentioned earlier, the schema will be in a format that makes sense to the upstream system, but it might not make sense to the organization as a whole or to the downstream systems. And so with this raw data, the first thing we're going to do once it's arrived in Kafka is we're actually going to apply some stream processing. And so if we think about we will have a stream processor, which is subscribing to this topic. It's doing something, as I said, to the topic. It's doing some kind of transformation. And in this case, this is just going to be a, it's just going to be a stateless sort of like schema transformation. So we're going to model, we're going to reshape the data, and then it's going to push that out into a another topic. And this is the pattern in Kafka. Things go into a topic. We can't modify them once they're in the topic. So we process them and create a new topic. And we will be repeating, that for each of these topics, all right? And so we're going to be processing each of those topics. Now, the technology, as I mentioned, is going to be KSQL DB. Right, so KSQL DB is going to be doing the stream processing and creating these kind of like output topics. All right. So what we're sort of like moving towards with that transformation is reshaping the data into a sort of state that's much more consumable across the organization. And so we sort of like, we start to think about this. We might think about this as kind of like, I've used a prefix, which probably isn't the best prefix, but I've called it global because it can be shared across the organization. This sort of like ties into concepts of data mesh. We're not going to go there, but it's got this idea of, well, you've got your domain specific data shapes, and then you've got the data, the schemas that you share across the organization in a productized way. And so you could imagine these events as being the kind of productized version of the data. And so we're not finished there. So the next thing that we're going to do is another bit of transformation. And so we are doing another stream processor. And this time, we're actually doing something kind of interesting. Well, I find all of this stuff interesting, you may not, but we're going to be applying state to these streams. So that may seem kind of like odd. How, stream state, what is that relationship? And so there's this thing called the stream table duality. So it's this idea that if we look at kind of like a string of events, and let's just imagine for a second that these events are somebody browsing kind of like Amazon and putting things into their cart because they're panicking about Christmas, guilty as charged, and then removing things. All right, so an event may be kind of like add one thing, add three things, then remove some things. And so each one of these individual events is a behavior that the customer has performed. And so if each of these events is basically representing one action an individual user has taken while browsing Amazon and filling up their cart, at the end, all right, so remember this is time-based. So at any point, the sum of those events, when viewed in a stateful way, is actually the cart contents, right? And let's just say it was one product, so it might be just a number in a cart. But there have been a number of behaviors or events that have led to that. So when viewed as a stream, events are really those individual events, and they fly through and they happen over time. When viewed as a table, we're actually sort of introducing this notion of, well, the sum total, the sum effect of these events is a particular state. Right? Maybe I spent too long explaining that, but so what we're actually looking at is listening to this kind of like this feed or these topics, and then finally turning them into another, basically another topic. This time it's a stateful topic. And so here I sort of like think of this as state. And there's a couple of reasons I've done that, but both are of importance. All right, so this global stream of events is important, and probably more important from a data warehouse point of view than the state. But the state is very important from a sort of an application point of view. And so this is where we start to see, at the end of the day, a business is made up of its data, and then we sometimes split that into sort of operational and analytic stuff. But the lines are blurring there. And so we see some of this real-time analytics for dashboarding, and then we see sort of the bigger sort of like big data analytics in the data warehouse. And so Kafka actually makes it really easy to sort of like do both. And hopefully we'll see that during the presentation. And then finally, we'll have these kind of like these three streams of state. And we're going to do something else that stream processing is capable of, which is we're going to join these three streams. Right, so we're actually going to create a stream processor. Well, I say we're going to create, much of this has been already created. It's in the oven. And then this is actually going to create our final stream, which will be our customer 360 view. So that's a current state of the customer. The nice thing about all of these queries, we get familiar with maybe a query that sort of like runs at a point in time. And so you issue the query, it does something, and then it returns a result. In stream processing, these queries are long running, they're persistent. And so that this query will just sit there and it will wait for more events to come in. And each time an event comes in, it will reprocess and it will create another event coming out. So once we've done that, we're going to look at ways of actually dropping this data into some downstream systems. So we're going to put that into a downstream database, this time Mongo. And MongoDB will be driving, well, in the example, it will be driving an application. We'll also be dropping this down into Snowflake. Oh, okay, so that's kind of like an overview. It probably took longer to do the overview than it will do to show you the system running, but that's okay. So I might pause there, see if there are any questions. Just looking in the chat, how do we decide creation of internal queue versus external queue? Okay, not sure if I understand the concept of internal versus external queue. Oh, maybe it's the stream processing, like the decision between a microservice and a stream processing application. But we can talk about sort of architectures, and particularly microservice architectures towards the end, because really what we're doing is we're driving a system that is hydrating a data source that is perfect for building these microservice applications. Okay, so now I'm going to flick over into Confluent Cloud. So Confluent Cloud is Confluent's cloud-based Kafka. And just from a technical, I don't even know what that word was. From a technical perspective, I'm working with Docker locally, and I'm working with Confluent Cloud, and then I'm working with Snowflake. All right, so those are those technologies I'm using to build this out. And I'm just going to jump into Confluent Cloud. And so Confluent Cloud is split up into kind of what we call environments. So this James demo is an environment. And in there, I can see I've got lots of clusters running across multiple cloud providers. So I've got something in GCP and something in Azure. I'm going to jump into this, AWS environment. And so when we land there, we can see that, well, there's data flowing through, and that's that's a big relief to me. So it's working. Well, something's moving through. And we talked about topics, and so obviously we could actually have a look at the topics. But I think probably more interesting is to look at this kind of topology of this stream processing application. And so I'm going to just jump into the KSQLDB editor. And so you'll recall I said KSQLDB is kind of like a stream processing engine. And so that's what we're looking at here. And I'm going to go in and have a look at the flow of this application. And so now we start to see a little bit of, almost spookily, if we look at this, what we're seeing here is something which is very similar to this diagram, right? In fact, it's probably almost the same, unless I've got something wrong. So this first one is this profile service. Remember I said I've got a MySQL database running. And so this first one is actually the direct CDC capture, the data flowing in, it's that raw data. And if I click on that and I can look at the messages, what we're going to notice is that the schema for that data is absolutely perfect for CDC. So we've got a before state and an after state and some metadata about the system that created it. But sharing that, putting that into a data warehouse, trying to tell your application developers to work with that schema, bit of a nightmare. So this is where I said the first thing we do is we create a stream processing application that will actually change the shape of that data. And so this create stream is actually the application. So let's have a little look, and I'll zoom in a bit here. So this is the code or the query that builds this stream processing application. And as I said, most of this will be vaguely familiar. So the things that might not be that familiar, create stream. Okay, well, that's just really an abstraction we place when we're doing stream processing. It sort of like sits over a topic, if you like. So we don't have to worry about that too much. The with is kind of like the table if we were doing a relational database query, but we're using a Kafka topic. And then you'll see some things where I'm actually manipulating the data. So the first thing is I've got some functions available to me. And so this cast function, and you probably recognize that. And so really what I'm doing is I'm changing the type, the customer ID, from an int into a string. And there are various reasons why I'm doing that. But and then we're also, you'll notice that I'm actually pulling out some data from that after data structure. So if we have a look in here, we've got this profile CDC after F name, so first name. So I'm grabbing the first name from the after object, and then I'm going to be naming that first name in my new stream. And then you can follow along. So we're basically pulling out first name, last name, address, etc. And then the other things that won't be familiar and like aren't that important for getting the gist of it, but we're doing some partitioning. So that's very important when we start to join data. But again, nothing to worry about now. And then this thing, emit changes. Okay, so that will be new. And emit changes is just telling Kafka, this is a long-running query. This query is persistent. Once I actually execute this, it will stay in my sort of like a persistent queries. All right. And so coming back, if we remember, when we looked at this profile CDC, we had this big, ugly object. We've run it through a stream processor, and now we can look at the global profile and see the shape of that data as it moves through. And so now we've actually turned that into something that's much more consumable across an organization. So again, without wanting to dwell, and I know ThoughtWorks have a lot of interest in data mesh, they created it, the concept. This is kind of like a productized version of that data. That we can have this documented, we can have this accessible across teams, etc. And then we go through, and you can see this next bit is this stateful transaction. So now what I'm doing is I'm creating a table that will be kept up to date with any changes from the customer. So the customer object will always appear up to date. And so if we have a look at this create table syntax, very sort of like similar to, I suppose, what we were just looking at, except we're saying create table. And because a table is stateful, it's like a group by query, right? We're actually grouping things. And so we use a couple of different functions. So I'm grouping by customer ID. So I can use the customer ID as is, that's fine. But then I'm using this latest by offset. And so latest by offset is a function that actually looks back into the stream of events and finds the last time this field was updated, and it uses that field. And so what we're doing is we're allowing those events to change part of the data structure, but we're creating a sort of like a complete view of the customer at the end. Then we have our group by, and again, emit changes, because this is another long-running query. And so we end up at this global profile state. And so in this topic, you won't notice much has changed, other than this will essentially be, there'll be one kind of record per customer, which gets updated. Okay, and then moving sort of like just very quickly, because we've got the general idea now, these loyalty events, right? So these loyalty events are being generated, as I said, like by a data generator, and they're, roughly between 1 and 3 seconds, we're creating new events. It's going through some history now, that's why it's scrolling so quickly. I'm not creating that many events. But if we look into sort of like an individual transaction, So I'll just pause that and look into a transaction. This is the shape of that data. Okay, so we have a transaction ID. We have a customer ID, but no information about the customer. We have points, and we have a vendor. So this is the point of sale where somebody bought something. Right, and so there's a little bit less to do with preparing this data. So that's the raw state. But I'm actually doing some cast conversion. So I'm changing the type, and I'm also partitioning based on a particular thing. Again, partitioning was that lower level technical thing you don't have to worry about at this point, but that's what's happening. And then we're emitting changes. And again, we end up with this stream of events, which, as I said, with the last one, it probably doesn't look much different. But then we start doing something a bit more interesting with our stateful transformation. So here we have the create table command. So again, another stream processing application written using a query. So if we have a look at that individual query, we can see it's going to look a little bit familiar because it's very similar to the other stateful queries. We're creating a table, state, and we're grabbing out, we're grouping based on customer ID. We're getting latest by offset. So remember, that's going back through that history of events and finding the last time that field changed. And then we're doing these kind of like these actual aggregations. Okay, so we're doing a sum of the loyalty event points, and we're calling that field total points. And we're also doing an average. So we're doing average points. Grouping by customer ID, emit changes, long running query. So that's kind of like, should be at least a little bit familiar. And so when we see the kind of like the results of this stateful aggregation, we're going to start to see kind of like a bit more of the reason why we do this. So we get the view of the customer, and so that's customer ID. You can see that it's been converted to a string. Got points, which is an integer. The last vendor, which was Chemist Warehouse here, and then we have the total points that this customer has accrued, and that is getting up there because I've been running this application for a while, but they really should cache those in. And then we've got the average points per transaction. All right, and that's over all time. So that's over the history of all of the events we've captured. And without sort of like belaboring the point, we do the same for that sort of like that credit rating. Remember, the credit rating was coming in via CSV, and so that CSV file would be essentially dropped into a directory, and these events would flow when the CSV file was actually. And then we see this bit, and this bit is where the customer 360 truly starts to happen. So we've prepared these three data streams. We've got kind of like profile information, we've got loyalty information, and we've got this credit, and we create this table. And so this create table is actually, again, some of this will be familiar, but there's a fair few things we introduce here. So create table, because we're doing a stateful aggregation. We're grouping on customer ID, but then we have these struct. So now I'm doing some manipulation on that data format. And so I'm placing these into basically objects, all right? So I'm creating a number of different objects that are going to be more useful for my downstream application. And I'm doing this based on a join between three tables, all right? So now we're actually joining three tables into one. We're manipulating the output format yet again, and we can see the final kind of the final output here, which is events which are structured in this way. So now I've got a customer 360 object, which has a customer ID. It has the profile, which is split into first name, last name. It has address, which is split into obviously the address fields. The latest loyalty transaction. So this is the most current transaction that this customer made, the vendor details, the points details, the transaction ID. And then we've got these loyalty aggregates. So these are the total points and the average points for that customer. And a credit score, which is coming in from that CSV. And so what we see here is kind of an end-to-end process for pulling this data in and then sort of like manipulating it. And then this customer 360 is actually, this topic is getting pushed down into a Mongo database, right? And so that's kind of like the overall operation of this, and probably useful at this point to prove that it's all working. And this is probably the most precarious part of any demo, is going into sort of like MySQLDB. All right, so MySQLDB running on my machine in Docker, and I'm running a Connect worker in Docker as well that's monitoring those logs in the customer. And if I go into this customers table and then I select data, we can see kind of like all of those records. Now, in terms of this demo, to see this kind of working, we probably need to go back in here, and we could probably start maybe at this profile, global profile stream. So this is kind of like what's being shared across the organization. And we can see that customer 1099, just have a look at customer 1099, Hugo Ellison. So Hugo Ellison has moved from Cecil Fold to a more sensibly named street. And we need to update, maybe the call center is updating in their system, that is updating MySQLDB. So I'm just going to make sure that that is still streaming and take note of 1099. And then we go into our MySQLDB. We look for user 1099, which of course is on the second page. And here we have Cecil Fold, Hugo Ellison. I edit Hugo Ellison and I move him to a much more sensible street, and I save that. Then I come back into Confluent Cloud, and it's actually already there, I believe. So Cecil now lives in George Street. And so that's actually flowed from my local system up, well, from MySQLDB through a connector up into Confluent Cloud through the stream processing application, and it's close to real time. And as we move along, and it may not be as easy to find this record in this view, but I think from memory, he was 1099. And so here we have Hugo Ellison living in George Street. So that's our customer 360 view. There we go, live demo. But good time to come down to Mongo database locally. So we were pulling in from MySQLDB, doing lots of processing, and then we have MongoDB again running in Docker on my system, but this time it's what we call a sync connector. So it's expecting data from Kafka, it's consuming from Kafka. And we can see here that if we want to look at Hugo's address, we can go to the ID, and it was 1099, and find him. And there we have him living in George Street. And so this is a full kind of loop of the data moving through the system. And we can validate that by going back to our MySQL database, and we can move Cecil to Smith Street. Oh, sorry, not Cecil, Hugo. Smith Street. I save that, and then I can come back to Mongo. This might take a little bit longer, but I'll give it a go. And we find that Cecil is now living in Smith Street. Now, I haven't built the application on top of this. I'm actually working on it, but I haven't built the app. But you can imagine this application might be driving a user interface for a customer. And so we're building a maybe an Angular app, which is kind of like the way the customer logs in, and they can see their latest transactions, etc., their current point history. And from an application development point of view, so from an operational data point of view, this data format, it's a single row to load. There's no querying other services to find out, oh, what is my loyalty points? What is this? What is that? This is just being kept up to date as data changes. And that's really the key point behind that data in motion paradigm of actually, when data changes somewhere, it flows through a system. And the final thing is to actually have a look at this in Snowflake. So in Snowflake here, I've hooked up this global customer, and we can actually preview that data. And we're getting, and we would probably find, although I don't know how this is all ordered, it's probably in the wrong order, but we would have somewhere here, we would have a piece of data that said Hugo was now living in Smith Street. And so how is that data getting in there? Well, let's have a look at a connector, because that's actually something I haven't really shown you. So to start with, the Snowflake connector. So go back to Confluent Cloud and we refresh and pretend that never happened. And I return to normal Zoom, and then did I just refresh again? I made a lot of jokes about live demos, but I actually thought it would be fine. So I think what I may have done is filled up a local browser cache, to be honest, because there is a lot of kind of like obviously browser side stuff happening here. And so I may have to log in via a browser with a called cache, but I'm just going to come back in and go back in here, and hopefully we don't get kind of like issues there, right? So I look into the data integration tab, and I have information about clients, so systems that are connected at the top and the bottom, and then I look at information about connectors. All right, and so I can see I've got this Snowflake Sync connector running. And that Snowflake Sync connector is how that data is moving from Kafka into Snowflake to cloud-based services. And we'll have a little look at this, this connector. So we can see that the connector is running. It will just take a moment for those messages processed so it's processed 113.5 thousand messages, and it's up to date currently. But if we actually have a look at the settings, this is how we set up this connection. So what we see here is I'm subscribing to this topics global customer 360, which is what we can see in Snowflake. But let's say, and you know what, to be honest, the customer 360 data set, because of stateful aggregation, probably not the most useful for data analytics. We're probably more interested in some of either those raw or those global streams before we made them stateful. So we can actually add, we can go through here and we can look for kind of like this, these loyalty events. And like, I might like, if I chose loyalty events here, I get the raw format. If I was to choose the loyalty events that's being processed by the stream, so the global loyalty events, I'll get the kind of process, the ETL'd shaped data. So I can click on that and add that into my connector. The other things that we do to set up this connector, obviously I set this up earlier, but we just really, we're using an API key for Kafka, and then we're actually using a private key to connect to Snowflake. There's a public key set up on Snowflake to make the, to finalize that handshake. And so I will just click on next, which will validate the changes that I've made. And then I will, before I hit launch, let's just go back to Snowflake, and we can see that we've got one table in there. So we go back to Confluent Cloud, and then I'm going to launch this connector. All right, and so that will take a few moments as it stops it and starts it. Okay, so that connector is running again. And then if we come back into Snowflake and refresh our interface here, we now have a new table in Snowflake. That table will be being populated. There'll probably, there's a bit more of a delay getting data into, like the data is coming from Kafka. Basically, we're loading it all up now. There's a few moments delay for Snowflake to actually capture those events, so nothing's come through yet. But we've actually created a whole new data stream in Snowflake. If we go back to Confluent Cloud, we can get an idea of how this application is set up by going into stream lineage. And so before we were looking at the stream processing application specifically, what we're looking at here is actually a much kind of broader view of the application. And it includes my custom kind of like apps here. So I've got a custom producer for customers. So that's my MySQL DB connector. I've got my events, and that's my kind of like data generator connector. You don't see the CSV connector because that CSV is sort of, it doesn't do like, it doesn't work like a connector that does a keep alive. So if I was to run, in fact, if the demo gods are going to allow this, if I was to move my credit CSV into a monitored folder, that would be picked up, and it's been picked up already. And what I expect to see, although I'm feeling more and more foolish for doing it, is changes to this diagram. Now, I can't remember if those changes will appear without me refreshing. They probably won't. But if I was to refresh here, what we would probably see is a third data source, and it may take a few moments for this to show up, but it's recognized that we've got a third connector. Okay, that's still recognizing that, but it will show up. Yeah, and so what we'll see is that third stream of events moving through from a custom producer. And then as we move through, we also see some interesting things here, okay? So this is kind of like that flow of the customer 360. And that customer 360 is being dropped down into MongoDB. So this is an external application. But here we have Snowflake. And so I can see that Snowflake is subscribing to two different data sources. And we can also see kind of like the amount of data that is currently moving. And that's because we're loading up all of that data into Snowflake. So that fat line says that it's a fat pipe. We're moving a lot of data into Snowflake. Yeah, so that's kind of like, I guess, the end of the demo. Now, some of the things that I haven't shown you is how sort of I've created those connectors locally, but they're actually very similar to that UI that I created for Snowflake, where we just actually use some configuration options to configure a connector to understand where the database is, where it's pushing data to, and so they're very well, relatively easy to set up. And then the final thing is kind of like when we're actually looking at these applications. I'm so tempted to go back to Stream Lineage to see if that third, yes, it has. Thank God. Okay, so now we can see we've got three things that kind of match up with the diagram, coming from three different connectors, and they're sort of like filling out that kind of like that overall view of my application topology. So the last thing that I was going to do was go back into this KSQL DB and actually have a look at some kind of like some other sort of like forms of these queries, right? And so these queries can be used for data exploration. So we can use some ad hoc queries in KSQL DB to get a view of the data. And so I should have one which I paired earlier. And so this one is kind of interesting, I think, because it's a stateful aggregation, but I'm actually tumbling it across a time window. So actually, in terms of that time window, so that we understand it, if you think about kind of like, well, this example I gave here, this sort of like this shopping cart example, because stream processing runs across, is persistent, we can actually break our events down into time windows. And this is the basis of a lot of things like fraud detection. The idea that it would be unusual for somebody to present the same credit card more than, say, 3 times in 5 seconds. So monitor a 5-second window. And if we see the same credit card number more than 3 times, create a new event, which would be a fraud event. And so having a look at that in a sort of like an exploratory way through this window, oh, I did it twice. So what we've got here is kind of like just a query that I'm writing. It's just a select query. And I'm going to have to add actually emit changes, and not that it makes any difference, but I'll just keep it all uppercase. Emit changes. And so what we're doing here is we're selecting the vendor and we're selecting the sum of points. Okay, so, and we're calling that total points from the global loyalty events. Okay, so from that earlier sort of like stream of loyalty events, we're windowing it in a 10-minute window, right? So we're actually capturing how many times this happens in 10 minutes, and then we're emitting changes. And I can run that query now, and that will start the process. An interesting thing about Kafka is, and something that often confuses, is this idea of the reset. So I'm going from latest. So I'm starting from any event that has entered the system, but I can also go from earliest, which will go through the whole history of events and build out these time windows. All right. And so I can see that IGA has a total of 100, well, it just went, but had a total of 613 points. But then, oh God, I should pause this, right? So let's just see if we can find sort of like two of the same. Okay, IGA 613, 922. And if we open this event, we can see that that's kind of like updating the state, the window of those IGA events. And so what we end up with is a 10-minute window or a leaderboard of vendors and how many points that they've been actually creating. And this is kind of like almost analytics, but it's also application, but it's real time. So the value of real time decays quickly over time. So being able to see a 10-minute window of what's actually happening at my point of sale, and then like matching that up maybe to a radio ad or a TV ad or something like that, can be immensely valuable. Now, if I like this query, if I feel like this is actually a query that I want to have part of my stream processing application, because at the moment I've just done a select statement, so it's quite similar to if you were doing it in MySQL DB. To turn this into a part of my application, I would say create table as select, right? So I'm creating a table. Actually, I need to give that vendor 10 minutes. I'll call that. Okay. Then 10 minutes and okay, I think that's all right. Create table, vendor 10 minutes as select statement. We've tested the select statement, seemed to work. I'm going to stop that. I'm going to run that. We got a success. If we go back to our stream topology, we suddenly see now we have this new topology over here, which is being created, and that can be pushed down to an application that can be queried via a dashboard, that kind of thing. And so we start to see that we've got window start, window end, and the total points for the application. And there's lots of semantics around this for late arriving events, etc. Wow, that was a lot of talking. Hopefully there's some people left on the call. I might really stop there because that's more or less all I had, unless anybody has any questions.
Yeah, James, we have some questions on the chat. If you want, I can just read out some of the questions.
Sure.
That'd be easier. Yeah. So I think there's a question from V. Could you also explain compacted stream, please?
Sure. And compacted stream, probably best done on the whiteboard. So if we think about kind of like this stream, I'm going to draw out another stream of events. There's compacted topics are a way of actually reducing the storage requirements for topic, and there are various other reasons we do it. Tables, by default, fun fact, but not important, are compacted. But if we think about a topic, okay, a topic is actually made up of what we call partitions, and then partitions are split into segments, right? And a segment is kind of, and we're getting kind of quite low level, but a segment is essentially a file on disk, right? So the way Kafka works is it opens a file, it writes events into that file, and at a set point, it actually closes off that file and opens a new file. And each of those files is a segment. Now, with the compacted topic, so it's a configuration you can set on a topic. With a compacted topic, once for any closed segment, so it never touches an open segment, but for any closed segment, it will run through all of the events. And what it will be looking for is actually the key of the event. So again, digging a bit deeper into how Kafka works, essentially there's headers, and then really there's a key and a value. And the key is not unique as it would be maybe like, it's not sort of like a database primary key, but the key is maybe something like customer ID. So if we imagine that a lot of these events had customer IDs associated with them, all right, and the ones that I'm circling were all for the same customer. With a compacted topic, as part of a sort of almost like a garbage collection process, for all of these closed segments, Kafka will go through, and first of all, it'll check to see if there's where the last occurrence was. And because there was an occurrence in this open segment, it knows that these are no longer required, right? Now, that's important to understand if they're required or not, because in some of the use cases I've just showed, they would be required, right? But it's a way of actually cleaning up these log segments, so we actually reduce storage on disk. And for stateful aggregations, because really we're always interested in the latest, it's a very safe kind of like a cleanup policy. One of the things that Confluent have introduced, both in Confluent Platform and Confluent Cloud, is this notion of infinite storage, which gets, I think, very interesting. It starts using a hot data set and a warm data set. And so that warm data set is actually pushed off to low-cost object storage. So something like S3. So we have some data running on disk on the machine and some pushed into S3. And so that's a way of actually making the economics of storing data for the long term stack up.
Thanks, James. And then we have a question from S. What is the best practice to manage connector configs? Effectively, it is a curl request to create connector.
Yeah, great question. So best practice is obviously using it via the REST. So there's two modes that I think we talked about Connect as a framework. So that's what we're talking about here. And so Connect will kind of like run in standalone mode, and that's kind of where it loads all of its configurations off a file on disk, or it can run in distributed mode. So it depends which mode you're running it in. But for production, we're normally running in distributed mode, which means that we initiate those connections via REST. And so there's a REST API. And actually, if we look at, if I look at kind of like, this is the code that's running some of the stuff, and if we go in and maybe we look at the customer configuration, what we have here and is the connect. This is the object that is setting up the connect task, and then I'm actually just pushing that all through curl to my local connect worker. So REST for distributed is always the way that we actually deploy. In terms of CI/CD pipelines, obviously you can build something like this into a CI/CD pipeline. Confluent are also working on a Terraform provider, which will allow you to define some of this in a declarative manner, and it will just appear when you deploy via Terraform. Hopefully that answers.
Yep. We have a question from Michael. Is there a practical limit on the size of each row of data, either with just structured data or binary data?
So when we say row of data, I interpret that as being an event. So is there a practical limit on the event size? There are practical limits, yeah. So by default, I believe the event size is 1 megabyte. Confluent Cloud, we've tested our platform and we're comfortable with event sizes up to 20 megabytes, right? If it's more than 20 megabytes, there are a couple of patterns that you can employ. The first would be if it's more than 20 megabytes, you're probably uploading some kind of binary object. So you could have a process where you're actually writing the binary object to object store, and you're actually passing the reference into the event along with some metadata. That's one approach. The other approach is very similar, I suppose, to sort of TCP approach of splitting things into packets. And then, so we split them at the producer. So we create maybe for 100 megabyte object that actually gets converted into 5 20 megabyte events with some header metadata. And then the consumer understands how to stitch those back together. So both approaches can be used.
Yeah, sounds great. There's one more question from Michael. Does it support array of structs? Example for perhaps multiple addresses per customer?
So for multiple addresses per customer, is that?
Yeah,
oh, okay.
I think it's probably, JSON-like sort of structure. Do you mean to say that, Michael?
So an array of kind of addresses associated with, so it will support kind of like whatever data you push in. The beautiful, well, a thing about Kafka is that it actually doesn't understand the data that's passing through it. For that, we use schema registry. Schema registry is where you define the schema that actually relates back to the events. And that's a very important part of the platform, because as we start spreading data and sharing it across the organization, pushing it into these data warehouses and applications, data quality becomes a real concern. And so that's where we actually apply a data schema so that any event that moves into the platform has to comply with that data schema. And so that data schema can be either Avro or Protobuf or JSON schema, and all of those kind of like will support the notion of an array of addresses, and yeah, so no problem.
Yeah, and there is a question about a difference between stateless and stateful.
Is there more to the question, or is it like? Would
you provide a brief explanation of stateless and stateful? I think somewhere you used something about state. I think probably that's when the question was asked from.
Yeah, sure. And like it's useful to think about maybe kind of like I suppose the database as a classic example of a state store. So if you think about a database, let's say it's doing a page count, right? So every time somebody looks at my website, it is terrible idea, but it is actually pinging the database and it's incrementing a count, all right? And so this will be made up of lots of different view events, right? So this user may have viewed it 10 times, and so there are 10 events. Oh, actually, okay, I'll finish this, but I think I know what the question was. And then there'll be a count, which is, okay, we've actually seen this 10 times. So that is state. That is actually running across multiple events. This is kind of stateless, where each event is unaware of the other event. And so both sort of coexist. And so when we actually translate that into something like, okay, SQL DB, table is the construct that represents state. So some kind of aggregation, some kind of awareness across events, whereas stream is the concept that represents these events, which are kind of like completely isolated, separate, and unaware of each other.
I hope that answers. I think that I found this useful. Yeah, thank you.
Okay, good.
There's a question about, I think it looks like lineage. Is there a way to keep track of where data is coming from and where it is flowing? Example, reporting on the data flow or something similar. Sounds like lineage, maybe which you've shown probably.
Yeah, I just put the chat across there. So yeah, like exactly what you're saying. So this lineage is actually kind of like an important concept, and I think my CSV is going to have disappeared because it won't have been pinging the application server. But this lineage shows my connected devices and how the data is moving through various topics and various applications, right? So it shows all of the active applications, and as if I was to add in additional applications, they would appear on this data lineage. I can actually download that as kind of like an image, but Kafka also has some underlying topology commands that you can actually pull out some information about the topology. One of the nice things that we've introduced is this idea of cluster linking, where you can have multiple Kafka clusters sharing data, and the lineage will be represented across those clusters. So you can actually understand the full path of that data.
Cool. Thanks, James. One last question which I had was, I think you covered briefly in between as well about the CI/CD, like all those streams and tables that we create. What's the recommended way of like creating those through? Yeah, I think briefly you covered about Terraform as well somewhere that we can use that. Are there any other recommended ways?
Yeah, so look, everything that I've shown is via the UI, obviously, and we have, so for KSQLDB, for example, I was writing queries into an editor. In the real world, like, I mean, you might use that for data exploration, but when you're building out a real production topology, those would be stored in files, and those files would be in Git, and those files would contain queries that were issued to a REST server that would deploy the queries. And so that could be part of a CI/CD pipeline or other process. So yeah, the UI quite often is useful, as I said, data exploration and building kind of like sort of like proof of concept, those kinds of things. But in the real world, we would normally have something a bit more robust in the way we build these.
Yeah. So would it be through Terraform, or are there any other ways as well, James?
Yeah, so Terraform is something that we've been working on. So it's not feature complete. It's kind of like an open preview, but we do have a CLI. So the CLI can actually be part of a CI/CD pipeline. You wrap that. It's a little less convenient than Terraform at this point, and which is why we're kind of like we're developing the Terraform provider. Yeah,
sounds good. Thanks. I think we have one more question. If there are different microservices populating different MS SQL Server DBs, can we enable CDC in MS SQL Server and use Confluent to set up real-time streaming analytics for BI reporting? And have you come across such situations before?
Yeah, absolutely. Like, I mean, that's a great use case, and so we do that very commonly, particularly in sort of like the financial services area. I mean, it's not MS SQL. Oh no, actually, yeah, sometimes it is. Sometimes it's Oracle. Sorry, I read MySQL and I was thinking, oh, well, they're not using MySQL, but MS SQL they definitely are using. And yeah, it's a really, really common use case, because when you think about some of those big core systems, they're quite often under a lot of, sort of like resource contention. So you don't want to be adding more queries. And so one of the first use cases in those big organizations is what we call mainframe offload. It doesn't have to be a mainframe, but basically it's a core system where we're actually capturing those events, pushing them into event streaming, and they're being used, for, as you say, for real-time BI, because we're getting real-time data, so like, sub-second, it's in the order of milliseconds. And we can create these reports. But important to note, fast data and reports through Kafka are powerful, but there's still a big role for the analytics use case where you're working with big data. And so both are important, but for different things.
Awesome. Thank you so much, James. I think that's all. And is there any way, if anyone has any questions later, is there a way people can reach out to you?
Well, that's almost like we planned this. So first of all, we have kind of like a slide that Ina will get angry at me if I don't present here, which is about sort of like the Confluent developer website. And also the local Kafka user group. If any of this has been of interest to you, we run Kafka user groups. And then for me, you can get in contact with Confluent if you're interested in like talking to somebody about a business use case, or for me personally, that's my Confluent email address and my LinkedIn link, I guess we'll call that.
Yeah. Thanks, James. This was super useful. And I hope everyone, I got some personal direct comments as well that everyone found it really, a lot of people found it really useful. So thank you so much.
Oh, fantastic. Yeah, pleasure.
Awesome. We'll move to community marketplace. I know it's already late, so we'll not spend a lot of time. So yeah, if there is anyone who has a job to offer or is looking for a job, feel free to unmute yourself and share your thoughts, or share the opportunity or your profile, resume, anything you want to can share in 60 minutes. Sorry, not 60 minutes, 60 seconds. And in case, if not now, feel free to put that in the Meetup page. And if anyone people would be there looking for, if, a job, they would look at it and maybe feel free to share it there. So, okay. So 1, 2, 3, no one. So, okay. Okay. Thanks, everyone. And thanks, James. And thanks to ThoughtWorks, who actually, they pay for the meetup joining and everything. So thanks to the audience as well. And thanks to James. And if there is, we'll have next meetup on 25th. And if there's any particular topic that you want to hear, let us know. Or if you want to speak and give a talk, feel free to let us know. We'll happy to host you. It's a place where you should feel free to share or whatever you worked on. It's a community, so you don't have to prepare a lot. You're most welcome. So thanks, everyone. Enjoy your evening. See you next time. Thank you, James, and thank you, Anna. It was really good. Thanks for the wonderful talk. It was really, really useful. And I'll share the recording as well.